People often say the Gulf Stream will collapse, but the Gulf Stream and the AMOC are not the same thing. Today we'll separate myth from physics, and see what a weakening AMOC would really mean. The Gulf Stream is a powerful warm surface current flowing along the U.S. East Coast toward the North Atlantic. It's primarily wind-driven, set up by Earth's rotation and large-scale wind patterns in the Atlantic Gyre. It meanders and shifts, but it doesn't just switch off like a light. The Atlantic Meridional Overturning Circulation, the AMOC, is three-dimensional. Warm, salty water flows north near the surface. In the subpolar North Atlantic, some of it cools, becomes denser, sinks, and returns south at depth. This density-driven overturning helps transport heat and carbon. The Gulf Stream is mostly wind-driven at the surface. The AMOC depends on density contrasts, temperature, and salinity. The Gulf Stream can persist even if overturning changes, but total northward heat transport can still fall if the AMOC weakens. Think, a fast surface highway versus a deep conveyor. Over recent decades, observations and reconstructions suggest the AMOC has likely weakened compared with the early 20th century. Exact magnitude and drivers are debated, but freshening and warming in the North Atlantic can reduce the tendency for surface waters to sink and form deep water. Possible outcomes include relative cooling of parts of the North Atlantic compared to the global mean, shifts in European rainfall patterns, dipoles in marine heat waves, sea level hotspots along sections of the U.S. East Coast, and changes in storm tracks. Not a Hollywood ice age, real but uneven impacts. The entire Gulf Stream does not halt overnight, Europe does not instantly plunge into an ice age, and not all extremes move in one direction. Regional patterns and seasons matter. We track the system with moored arrays like RAPID at 26. 5° N, the OSNAP array across the subpolar North Atlantic, satellite altimetry, and thousands of Argo floats profiling temperature and salinity. These records reveal how heat and salt move and how density contrasts evolve. Arctic amplification reduces the pole to equator temperature contrast. That doesn't turn off the Gulf Stream, but it can alter the balance of winds and density that influence overturning and regional climate. Models show that an AMOC collapse, a large, abrupt transition, is physically possible under strong freshwater forcing. The timing and likelihood this century are uncertain. Risk isn't zero, but certainty is not warranted. Maps often overlay the surface Gulf Stream path on diagrams of the deep overturning, as if they were interchangeable. In reality, they're different pieces of the circulation puzzle. Conflating them fuels the Gulf Stream will stop myth. For Europe, not a permanent deep chill, but potential shifts in rainfall and storminess atop global warming. For the US East Coast, periods of faster than average sea level rise tied to circulation changes. For marine ecosystems, regional winners and losers as temperature and nutrients adjust. Confidence is higher in the sign of some regional effects than in exact magnitudes or timing. That's why long, continuous measurements from rapid, OSNAP, Argo, and satellites are vital. They separate real trends from short-term variability and test models that project future change. Improve observations and models, stress test infrastructure against sea level hotspots and rainfall shifts, factor circulation uncertainty into fisheries, coastal management and insurance. Adaptation beats alarmism. AMOC and the Gulf Stream are different connected pieces of one ocean. A weaker AMOC matters, but myth and panic don't help. Measurement, models and smart adaptation do.